All right, atomic theory number 4. Last time we talked about light, and light comes in little uh, photons, which are tiny packages of light energy. They have specific amounts of energy. You cannot get any amount of energy in a photon. They come in very specific amounts of energy, and that energy depends on the frequency of the light. So Bohr used these ideas, and he came up with the Bohr model of the atom. He was Danish. 1913 is when he came up with his theory. His model had 3 key points. Electrons can only be in specific allowed energy levels, and he called them stationary states. Okay? Electrons in stationary states do not emit energy, which is it's kind of a cop-out, but that was his theory. He was basically saying, no, when an electron's in one of those states, it's happy. It doesn't need to give off energy. It's very content there. Now, when an electron moves to a higher energy level, it needs to absorb that specific amount of energy. And if it moves to a lower energy level, it's got to emit that specific amount of energy. Okay. And I have a little picture here from Encyclopedia Britannica of the Bohr model. So electrons move in, he said, circular orbits. Orbits are labeled with an integer. The closest to the nucleus is called level 1, then level 2, then level 3. These radii are fixed, and so if an electron is, let's say here, and let's say here, and it wants to move up to level 4, it's going to have to absorb a photon of energy of exactly this much energy. Not a little bit more, not a little bit less. If it doesn't absorb the exact amount of energy, it doesn't go. And if this electron wanted to move down to level 1, it's going to give off a photon of energy, and it's going to be the exact amount of energy. That's going to be the energy difference between level 2 and level 1. Not a little bit more, not a little bit less, exactly. So all these transitions are very exact, and that corresponds to the atomic spectrums that we looked at in the last video. So those different colors, and I don't know if you remember, but they're a little thing like this, and there are different colors, a red, a yellow, yes, different colors. Each of these is a transition from 1 to 2, or 1 to 3, or 2 to 3, or 2 to 4, depending on the electrons in the atom and the atom itself. That's what these lines are. They're showing all these different transitions, possible transitions from different levels. And so this was Bohr's Bohr's nuclear model. But look, sad face, it only worked for H, or a two-body system, a nucleus and one electron. As soon as I threw another electron in there, if I may, if I throw in another electron, well, let's not first. Let's pretend there's just one here. I've got an interaction here, true? Between these two particles. But now when I put another one here, I've got an interaction here, an interaction here, and an interaction here. I went from one interaction to now 3. If I put another one, let's say here, I have an interaction here, and here, and here. Yes, the number of interactions goes up very quickly when I start adding in more particles, and the math becomes complicated and unsolvable. So it only worked for H, and so they needed a brand new theory, and that theory was called quantum mechanics, and that will be the subject of our next video.